So if you'll now look at the back side of your paper, the original or the parent function for or of the square root of x is still there. Again, just drawing it in a little more clearly. So if you sketch this graph, 1/2 a square root of x, if you put that in your calculator and compare the graphs, this point will be the same, but then the graph essentially has been kind of squashed. The y values have been cut in half. And then if you will graph this function in your calculator along with the original, you can clear out the one that's in pink. Again, this point will be the same, but the others have been stretched vertically, and that last one, in fact, will come up to there. It's been stretched vertically. Again, still with the curve. The pink one doesn't look so much like a curve, but they are still curved. But all three of those graphs start at 0. They go to the right forever, and they're all three increasing forever, although the red graph is increasing much more quickly than either the original parent function or that pink function. So how does the radicals coefficient change the graph? The steepness or the vertical stretch, the vertical shrink changes. And remember, if the number in front, I'll call it just A, because that's what you will typically see, is greater than 1, such with this function, it is a vertical stretch. If that value of A is between 0 and 1, like a half or a third or 2/5, 3/4, whatever, some fraction between 0 and 1, that's going to cause a vertical shrink. But with a vertical stretch or vertical shrink, the domain and range are not affected. So no, they are not affected. The domain and range are only affected with a shift left, right, up, down, or if a graph is reflected across the X or Y axis. So beneath the line on the back side of your paper, your instructions say to sketch the graph of the cube root of X. So first of all, remember the cube root feature on your calculator. You would need to go to y equals first and then go to math 4 to get that cube root feature. You could enter this function using rational exponents by saying x raised to the 1/3 power. Okay, remember flower power. Those rational or fractional powers give you your roots. But either way you enter it in your calculator, if you look at some points, you've got a point at 0, 0, 1, 1, -1, -1, 8, 2, -8, -2. And those are the only points that you'd be able to plot on this graph. But that curve does something sort of like that. So in terms of domain and range, the graph goes left and right forever. And even though it is slow, the graph will also go up and down forever. So when we state the domain, you can say that the domain is all real numbers. You can use your little R symbol. In interval notation, we would go -infinity to +infinity. And then the range is very similar. Since that graph does go up and down forever, in interval notation, you're going from -infinity all the way down to +infinity all the way up. So that is what all real numbers looks like written in interval notation. So the next two examples on your paper are translating the cube root function. So for this one, that should be a translation of up 4 units. So if you compare the original, which I'll sketch back on my graph kind of quickly, if the original function looks something like that, then the translation up 4 would be something kind of like this. Okay. So if there is such a thing as parallel curves, those would be parallel curves. When you look at this next one in your calculator, that graph has been shifted left 2 with respect to the original. So if I get the original again back on my graph, and then shift those points left 2, so that point will go there, just shifting everything to the left 2. That curve moves, but that's really all that changes. So the very last question asks, what do you notice about each of the domains and ranges of the cube root function? Well, no matter what happens, when you look at this purple graph, it's going to go to the left and to the right forever. And the same thing with this purple graph, left and right forever. So the domain is still negative infinity to infinity, or all real numbers. When you think about the range, again, the graph is still going up forever and it's still going down forever, although slowly. And the same thing here, still up forever, still down forever, although slowly. So the range will also be all real numbers or negative infinity to infinity on those cube root functions. So on your homework assignment, you are sketching the graphs of functions. You don't have to sketch the parent function, but it might be helpful. But you're also listing off the translations, how have the graphs changed with respect to the original, and you're also providing the domain and the range. I believe your instructions say to do both inequality and interval notation, but I'm going to change that to just say interval notation. So on your homework, on the graphing radical functions homework, you only have to write the domain and range in interval notation.